Hi, I'd like to give an overview of sorting algorithms. So for many of us, well, at least those of us who study Python and computer science at Foothill, one of the first kind of non-trivial function or algorithm that we wrote was bubble sort. And so bubble sort obviously was, one of the sorting algorithms. Now, sorting has been very, very well studied from the very early days of computing, and for a number of reasons. Well, first of all, it's a very familiar thing that we do, right? Even in our daily lives, we do a lot of sorting of non-computational things. Right? And also, it's really a very useful process. That's why we do so much of it in our lives, as well as in coding. For example, we've also studied binary search, and binary search requires that the thing we search through is sorted. And then finally, despite its familiarity and possibly simplicity at first glance, it's actually not that easy to come up with an efficient solution, as we can kind of see in the bubble sort, right? So it's also a challenging problem, and that's why over the years, um, uh, many sorting algorithms have been invented and well studied, and even nowadays there are still new sorting algorithms that show up. And so now I just want to give a formal definition of what a sorting algorithm is. So according to Wikipedia, the output of any sorting algorithm must satisfy two conditions. So the first one is the output must in a non-decreasing order. And that kind of means each element is not smaller than the previous element according to some total ordering. Okay, so this is very important. This does not mean that the number one has always have to come before number two, right? So if the desired total order is such that the number two comes before number one, then so be it. So the important thing is whatever order you decide, um, the output must be in non-decreasing order. Okay, it could be equal, and that's why it doesn't say increasing, right? There are certain things, two items can be equal, and that's fine too. And then the second condition is that the output must be a permutation of the input, meaning we must not add more to the input, we must not remove from the input, right, in the output. The output must be, have the same elements as the input. Okay, and so one of the most important thing about sorting algorithms, other than they must be correct, it's their performance. And we've already learned previously that bubble sort is out of n squared, and anything that is n squared is slow. Okay, and then just very recently we kind of work with you're asked to work with the heap sort, which uses the min heap, and that is faster than bubble sort. So and you were asked to kind of estimate its big O. So this week and next we'll study a few more sorting algorithms, and all of them are faster than bubble sort, which is good. You really don't want to get any slower than what bubble sort already does. Okay. One of the common questions that we always talk about when we look at a sorting algorithm is, does it sort the input itself, or do we create a new list with the sorted input? So if you look at Python, there are two very common ways of sorting something. One is use the sorted built-in function. So sorted, when it's given an iterable, it returns a new list of the sorted elements. So it does not sort the iterable, the input itself. It returns a new list. And then another way to say, given a list, you want to sort the list, then you can do list.sort, which is list kind of own build method. And this method sorts the list itself. So it changes the list itself, and it does not return anything. So we have two choices, and for the sorting functions that we'll implement, it will sort the input itself. In other words, it's sorted in place. And this is just so that it's consistent with what we've already done with bubble sort, and also with what the reading presents. And then finally, another very common thing is for all of these sorting algorithms, and most of them kind of require that we can either read or write any element in the input in constant time. So, and that is possible if the input is in an array, just in most other languages, right? But we've talked about this before. Python doesn't necessarily have something that it calls an array. It has the closest thing it has is a list. Although, as we know, Python list is very close to array in other languages. So we'll use the terminology list of elements in the rest of the lectures. But just keep in mind that when we say list, it's not the linked list, but it's an array.